Hey everybody, Mr. Love here. Going to do a quick problem with horizontal projectile motion, and really this problem you see it in lots of different ways, and it's a fairly simple setup. The idea is that you're taking an object, you're firing it off of a cliff that looks something like what we have here, and there's a couple pieces of information that are given. What we talked about in class was the idea of writing in or filling out a table that had some of the information, and so we'll make the table over here just to keep things straight, x and y. And the things that we're going to look at are acceleration, initial velocity, and the distance traveled here. And in this problem, there is no friction, no air resistance, so the acceleration in the x direction is equal to 0. The acceleration in the y direction we're going to call 9.8 meters per second squared. We're considering down to be positive. That's the easiest way to set this up. And in this problem, the initial velocity v, we're going to say that's equal to 20 meters per second. So we can fill this in here, 20 meters per second. Because it's horizontal, there is no y velocity, so that's 0. The distance of this cliff is 50 meters. 50 meters, that's there. And, oh, that's in the wrong spot. Fix this. See if we can erase this. That doesn't go there. The y distance is 50 meters. That's the distance it falls. The distance it travels is the x distance, which is this distance here, dx. And so the most important thing that we need to worry about here is the time. And we had this discussion in class. The time it takes for this to hit the ground is the same as if you had let it simply fall straight down. And so the way that we're going to solve for that is using the distance equation that we've seen before. D is equal to VIT plus 1/2 AT squared. And this is in the y direction, VIY, AY. VIY is equal to 0, so this term drops out. And so you're left with dy is equal to 1/2 AT squared. And when we solve this equation for t is equal to 2d divided by a, and this is ay, both are y, and that's the square root of this. Plug in some numbers, and we get the root of 2 times 50 meters divided by 9.8 meters per second, and the time that we get is equal to 3.19 seconds. Okay, so the time it takes for this object to fall down is equal to 3.19 seconds. Now the next question that's always asked is, what's the range? Okay, and actually in this problem the range is the easy part. Once we have the time, and we said the time is equal to 3.19 seconds, the range is given by the simple velocity relationship for unaccelerated motion. Dx is equal to Vx times time, so dx is equal to the initial x velocity, 20 meters per second, times the time, which is 3.19 seconds. Dx is equal to 63.9 meters. Okay, so if we look back at this distance here is 63.9 meters. And that's it to solving a horizontal projectile motion problem.